touching, touch, and two. The first is spindle. If the muscle specific little structure within the muscle itself, and it has specific little types of neurons and specific little type of innervation we don't have to know anything about. And the sensory neurons associated with them, when this gets stretched, because you have relaxed, you have stretched the muscle, like if you're doing yoga, you're stretching, then it's going to start sending action potentials to start contracting that muscle slightly if you're overstretching. Now, the second type of proprioceptor is going to be in the tendon net, and it's called a Golgi tendon organ. So yes, the same dude who came up with the Golgi apparatus in the cell also came up with this structure within the tendon of skeletal muscle. And this is going to come in to be involved when the muscle is contracting too much. So when the muscle contracts too much, the Golgi tendon organ senses this, senses the force, and then the Golgi tendon organ starts sending action potentials to the brain that says, relax this muscle. So these are kind of working the yin to the yang to make sure you're not overstretching the muscle, and to make sure you're not putting too much of loading to this muscle. So those are the receptors. The second type were skin receptors. I'm going to talk about 4 different ones. The first are free nerve endings. These can be in the epithelium of the skin, or they can be underneath the epithelium. And these are just free nerve endings, so just think of dendrites there. And they look exactly the same, whether they are sensing heat or whether they're sensing cold. But we have about 80%. The second type of skin receptor looks like if you cut an onion in half, doesn't it? This one is located very deep in the skin, or it can be in the adipose tissue underneath the skin. And so this would take quite deep pressure. Olga's massage, but the more likely of activating this is if you have some type of vibration going on, like if you're holding onto a jackhammer, that would take this and this. So yes, it's receptors you will need to know. The third type of skin receptor is called a Meissner corpuscle. It kind of looks like the cotton ball end of a Q-tip. And it sits in the upward part of the dermis of your skin. And this is going to be activated with some touch, and it gives us what we call 2-point discrimination. We have a lot of these in our fingertips, in our lips, in our tongue, in our nipples, and in some of our external genitalia, like your penis and your genitalia. And so what this allows, where you have a lot of them, it allows you to tell that you're being touched in more than one place. So we don't have a lot of them, like for instance, in our back. And so, for instance, if I touched you at this distance in your back, let me do it here where there's a white background, you would be able to tell that I had touched you. If I touched you with two pins this far apart, you wouldn't be able to tell I was touching you with two pins. You would think it was just one pin. And so, but if I did that in your skin, in your fingertips or your nipples, your genitalia, I would have to just be a couple millimeters apart before you wouldn't be able to tell I was touching you with two pins. So those are your mycin muscles. And the last one that we're going to talk about, oh no, there's two more. Merkel cells. So Merkel cells are in the epithelium of your skin. And they're specialized cells that have Merkel discs, which are the specialized dendrites of the sensory neurons attached to them. So the cell is this pink thing, and the disc is this black part, which is the dendrite of the sensory neuron attached to them. And so these are on the epithelium of your skin. So these become activated with very light touch, which is not like the light touch of me touching you, but it would be like if, for instance, I took a feather and touched your skin with a feather. That would activate your Merkel cells. And the last type of skin receptor would be those nerve endings that form what we call a root hair plexus. Did you know around the hair root of every single hair on your body, there is a nerve? So yes, if I just touch one hair, if I move one hair, I can tell. Any one hair anywhere on your body, you're going to get sensory input from that. Okay. Now, the last type we're going to talk about are the nociceptors. And in a word, these are your pain receptors. They're just naked dendrites of sensory neurons. They're located in your skin, but also in your internal organs, where most of the time in your internal organs, they're going to be activated from stretch, okay? Because they're not activated from pain. We don't get a lot from tissue damage, is usually from stretch. But they will respond to chemicals released from damaged cells, as well as inflammatory cells. But in internal organs, the stretch will give us pain before the damaged cells and the inflammatory cells. So that's why they also respond to smooth muscle stretch, as well as tissue damage from low oxygen content. And so this was that substance P I talked about previously. But here's the thing about nociceptors and the sensory input is we can change this sensory input from the sensory neurons, from our expectations. If we think it's going to hurt us, it's going to hurt us. But if we don't think it's going to hurt us that much, it's not going to hurt us much. So for instance, little kids get 18 shots by the time they're 2 years old as part of their immunization sequence. And if, as parents, you lie to them and tell them it's not going to hurt, they know you've lied to them, and they will start crying long before the needle touches them. But if you tell them it's just a pinprick and it's going to hurt them, but look, as soon as you're done, we get to go, and you have them thinking about something exciting, like we're going to the park, or we're going out to eat, or you get to go do this, and they're thinking positive. They're not focusing on pain. It's most of the time they're not even going to. And if you think culturally, like community expected not to have reactions to minimal pain. The expectations change. The but it happens even though the limit fact. And so if you are in an emotional state when this is occurring, you're going to have a lot worse pain than if you're not emotional at the time this occurs. So that's it for this section. Come back as we start talking about our special senses. We'll start with the chemoreceptors that are involved with taste and smell. So we'll see you soon. Thank you so much.